All right, peeps, let's go ahead and do 6, 8, and 10 on your assignment today. Problem number 6 is a 45, 45, 90. Okay, so I'll talk about the pattern in a little bit. But before we do that, if you want to know the shortcut to doing problems like these, watch the video on Monday. They have a shortcut for this. I'm going to continue doing it the long way just so I don't have confusion if I try to show you two different methods. But if you want to attempt a shortcut, watch Monday's video. Last week's Monday and this week's Monday. All right, so let's get into problem number 6. It's a 45, 45, 90. Across from the 45, we want to remember the pattern is going to be a length of 1. Across from this 45 degree is 1. And across from this 90 degree is radical 2. So what we're going to do is set up a matching triangle here. And we know that's 90, here's my 45, and we're matching to my original triangle in problem number 6 here. Okay, so now we're going to put its new sides. The new side is 45, across from 45 is 1, across from this 45 is also 1, and across from my 90 degree here is going to be radical 2. Now, to solve, we're going to set up two fractions equal to each other. So let's do that now. So we're going to have two fractions equal to each other. So the first fraction I want to do is I want to take one of my original sides and match it to one of my new sides. But the rule is for your first fraction, you want to make sure the sides you match are actually numbers. No variables can be in this first fraction. So if you look, the original side that has a number is this guy at the bottom. And the original side that matches this side in the new is also the bottom, which is 1. So 2 times radical 2 matches with 1. So that's going to create my first fraction. Original over new. So 2 is my original, 2 radical 2 over 1 from my new. And again, I got 2 radical 2 from here. And then it matches with a 1, so it goes on the bottom. Now we're going to put it equal to another fraction, and I'm going to solve for y. So y has to be in this new fraction. So since y is in the original, y will go on top. And since y is the one we are using, who does y match with in my new? It matches with 1. Okay, and now we're just going to cross multiply and solve. So that gives me y equal to 2 times radical 2, and since y is already solved for, this is my final answer. All right, we're going to do the same thing and set up the same fraction for x. Okay, we always want to start with this fraction that we created using just numbers. So I'm going to use this guy again. Okay, so 2 radical 2 over 1 equals, and then we want to create a fraction with x in it. So the fraction we could use with x is here. He's going to go on top because he's the original. Who does x match with? X matches with radical 2 in my new, so radical 2 goes on the bottom. And now we cross multiply and solve. So this gives me x equals, and that gives me 2 radical 4. Okay, and I got 4 because radical 2 times radical 2 is radical 4. Remember, square roots can multiply with each other. Now we actually can clean this up. So it's 2 times radical 4, or square root of 4, and the square root of 4 is going to be 2. So x equals 2 times square root of 4, which is 2. Do this math, x equals 4, and we are done. All right, number 8 uses last week's pattern, which is a 30, 60, and 90. So if you remember, we have to know the pattern across from these. So across from the 30 is a 1, across from the 60 is a radical 3, and across from the 90 is 2. So again, this is very helpful that you memorize these things here. So once we have that, we already know this guy over here is going to be a 30. So we want to draw a direct copy of this okay? But we're gonna put in our new side measures. So the original side measures are on top. We're gonna replace them with new side measures in my red triangle using this pattern. So across from the 30 degree, here's my 30. Across from it, the side across from it is gonna be 1. That's called the short side. Across from the 60 is radical 3. So across from the 60 is radical 3. That's my long side. And my cross from the 90, which is my hypotenuse, is going to, again, across from the 90 is going to be 2, which is my hypotenuse. All right, so now we're going to kind of do the same thing. We're going to match and set up equations. So I want to match one of the sides over here that has numbers only, no variables, with the side over here. And it should only be numbers. So we're going to take original. This is the only side that has numbers. So this is my original. So it's going to create my first fraction. Okay, he matches with 2. So he goes on the bottom. So original over new. Original over new equal to. And now we want to match it with a variable. So I'm going to choose x again. So x is going to go on top because it's original. And who does x match with over here? He matches with radical 3. Okay, let's cross multiply and solve now. So it's going to be 2x equal to, and then cross multiply here, 6 radical or square root of 9. Again, radical 3 times radical 3 is radical 9. Okay, we could actually clean this up now. So let's move this over here. That's 2x equals 6 times 3, because the square root of 9 is 3. Multiply that out. 2x equals 18. And then solve for x. 2, divide 2 to both sides. X equals 9. Okay, so we solve for x. Now we want to solve for y. So we're going to use, again, our original fraction here that we first created with numbers. So it's going to be 6 radical 3 over 2. Equals, and then we set up a fraction using y. Since y is my original, he goes on top. So y is my original. Who does he match with? He matches with 1, so 1's going to go underneath here. Cross multiply and solve. We have 2y equal to 6 times radical 3. We cannot clean this up, so we leave it as is, but we can solve for y by dividing by 2. So we have y equals 6 times radical 3 over 2. And if you notice, I actually can reduce these outside numbers. 6 can be reduced by 2, and it turns into 3. Or 6 divided by 2, this turns into 3. 2 cannot divide this guy because it's in a radical. So it's going to be y equals 3 radical 3. All right. Okay, guys, number 10 is a little more complex. Our ultimate goal is to solve for x here. Okay? So if you look, to solve for x, we are simply going to use this, which is a 45, 45, 90. The problem with this is that we don't know another side. We don't know the measurement of this side, or this side. So we can't just simply use this right triangle. What we have to do is, in other words, we now have to use this right 45, 45, 90. And if you look, if I can solve this side, it is actually one of the sides of this triangle that will then help me solve this side. So here's the plan. we want to solve this side here. Let me highlight it for you. Our goal is to solve this side. If I can solve that side, I then can use this side to solve that side. Okay? So what we want to do is we are going to ignore this triangle first. Okay? And our goal is to solve for this side. So we have to remember our pattern of 45, 45, 90. Okay, I'm not going to write that down again, but we're going to make an exact copy here. So here's an exact copy of this triangle, which is 45 here, 45 here, and then we are going to label this with our new sides. So across from the 45 we always know is 1. Across from this 45 we also know is 1. And across from the 90 we know as radical 2. Okay, so let's set up a fraction. And again, our goal is to solve this side right here. So we'll call this side y. Okay, so we want to solve for y. To solve for y here, we're going to match 10 because it's a number with its matching part here, radical 2. So it's going to be 10 over radical 2. So 10 over radical 2 equal to, and we want to solve for y, so y is going to go on top because it's one of the originals, and y matches with 1. Okay, cross multiply to solve. We got radical 2 times y equals 10. So let's solve for y. We're going to divide both sides by radical 2. And we get y equals 10 over radical 2. But if you remember, there's a rule. You cannot have a radical in the denominator. Okay, so we're going to do what is called rationalizing the denominator. We cannot have a square root down here. So to do that, we simply multiply the bottom by the same radical. What you do to the bottom, you do to the top. Okay, and watch what happens. On top, we get 10 radical 2. That's pretty simple. Or 10 times radical 2. On the bottom, the square root of 2 times the square root of 2 is actually the square root of 4. And the square root of 4 is just 2. So y equals 10, radical 2 on top. Nothing happens there. But the bottom now turns to 2. And then, if you look, I can reduce 10 and 2. I can divide those. 10 divided by 2 is 5. So y is actually 5 radical 2. Okay, so I'm going to place this into my drawing. So instead of y, what we have is 5 radical 2. Okay, now this is not my final answer. We're going to use it to solve here. So I'm going to make this guy appear again. Okay, and now we don't need this bottom triangle here. So we're going to just use this information now. Oops. Okay, let me get rid of this guy. So now we can just go ahead and solve this triangle. So we're going to do the same process again. It's a 45, 45, so we're going to draw our copy. Okay, this is 45, 45. Across from the 45s are 1. Across from the 90 is radical 2. And then we are going to match. So here's my original. Here's my new. So I want to match numbers first. So 5 radical 2 matches with radical 2. So 5 radical 2 is going to match with radical 2. Equal, and now I want to solve for x. So x matches with this guy over here. So x over 1. Cross multiply and solve. So we got radical 2 times x equals 5 radical 2. And then to solve for x, we're going to divide both sides by radical 2. And if you do the math correctly, these radical 2's also cancel out, so x is equal to 5. And we are done. Hopefully this helps, and hopefully you guys are doing well.